Welcome back. My name is Daniel Hall. I'm assistant professor at TU Delft University of Technology. And I will introduce our next session, but in a moment, but first I want to say we had some questions about slide distribution, and maybe to make it clear for everyone, we don't distribute the slides from the event, but we have a professional recording which is done, which we will distribute to audience members usually about 2 weeks after the presentations, after we have a chance to kind of edit and put them together nicely. We also then do release these to the public after about 6 months, but for those of you that attend, you will have also a recording of the session. So if you're wondering about capturing everything, that's the way that we distribute after the event. Fantastic. Well, I'm here to introduce our next session, which was already mentioned a lot in the early part of the morning, which was the topic of design. So I find that to be quite interesting. A little bit about my background. A long time ago, hard to remember how long ago, I started my bachelor's degree in a topic called architectural engineering at a school about 4 hours drive south down the 101 called Cal Poly, San Luis Obispo. I know there's at least 2 alumni here in the room, so maybe more. This was before I really was focused on construction, but it was a program that focused on structural engineering and also architectural design studios. And so from a very early part of my career, I was very aware of the need for multiple disciplines to collaborate together. Then over time, as I became more involved with construction, and in particular with the topic of industrialized construction, I've always felt there's a really important need to have a conversation about what design looks like in the context of an industrialized construction system. We have already heard, we don't want to just make blocks and modules which are very stale and stagnant and don't really fit the needs of architectural and structural design that we might all know today. And it's become even more relevant to me now that I've moved to my current university and I work in a faculty of architecture, where we are having that conversation also about what that looks like in the future. So as we began to think about this, the topic of fabrication-aware design became the word that I've really anchored to in my career. And the idea is that it's very important that we have a design language, we have a design approach, but it's also very important that we think about the fabrication systems and the approach to fabrication. Now the challenge is bringing those 2 things together, right? And I think that's what we're hoping that the next set of speakers will be able to deliver to us. So with all of that, I'm really happy to kick off the session with our first speaker, and that is Sarah Ann Logan, who is the head of design and the principal architect at VBC. So with that, Sarah, welcome. The floor is yours.
What I want to talk to you about today is really the influences not only on my career, but what the decisions that we've made at VBC and why we've made those decisions. A lot of those decisions have been commercial in nature. A lot of those decisions have been product and design driven, but all of them are intended to speed things through the manufacturing facility and keep factories full, which can be sometimes disparate and not always aligned in goal. So I wear lots of different hats. I still maintain my title as an architect. I actually stamp all of the projects that we do, which is kind of crazy. But to that end, there's a lot of technical things that I'm going to be talking about, and then just a lot of strategy things as well, how we got here and what our future holds. Let's see. This image actually is our first, yes. Yep, and then I'm just hitting this one, okay. This image is one that we're really proud of. It's our first our first development project. So as VBC, it's the first one that we're doing. It's in our home market of Philadelphia. It's wood construction, 5 stories of wood construction over 2 stories of concrete and steel, type 1A construction on the bottom 2 floors. Residential, very high density apartments. They're very small apartments. Most of the apartments are 450 square feet or under. So studios, junior 1 bedrooms, and 2 bedrooms. So that's me being an architect. I will move on. So what does VBC do? I think it's important to explain all of the things that come under our umbrella so that you can understand exactly why we've made the decisions we've made. So we're fully vertically integrated. We have the design and architecture practice and integrated engineering, which I run. We have 3 different manufacturing facilities, which we'll go to next. And then we have what we call our sandbox construction company. So they manage all of our sets and transportation on all the projects that we do globally, actually. And they do perform general contracting services within our home market of Philadelphia. This is our California facility. It was formerly a Katerra facility, and we've rebuilt everything inside of it to support our wood building system. It's large. We would not have we wouldn't have bought such a big facility, but we inherited it, so we rebuilt it, and it's now running. It's in operation daily. And we are now on to our 5th project going through that facility, which is great. Highly automated, very different than the next facility I'm going to show you. Only builds wood, currently. TBD on that one, but currently it has only ever produced wood. Berwick, Pennsylvania. This is a historic Pennsylvania facility. It is not automated in any way. There is no automation incorporated in this. The people at this facility have about 1,200 years of combined volumetric modular construction experience. So very, very highly trained workforce, which is depleting, but has also, in this facility, has built historically wood and steel product. And then the 3rd facility, which we have a steel facility in Poland, in Chojnica and Gdynia, Poland, that not only manufactures steel modules, but also we have an automated furniture production facility that's next door. Why am I showing you all of these? It is really difficult to manage the product strategy on wood and steel at this scale globally. It is very difficult, and without having really a platform-based strategy, there would be no way that we could be successful at doing this. And so a lot of this came through the thought processes and that are involved in design thinking. How can we find combined inherent things that are similar in all of the markets that we work with? How can we optimize those, and how can we have really an amazing set of industrial designers, manufacturing engineers, architects who can speak the same language and don't get annoyed by being in the same room with each other? And then also be able to collaborate with contractors, electricians, plumbers, unions, in an ecosystem that doesn't necessarily always play nice in the sandbox. So that's what we're trying to solve at VBC. We hope that the future of industrialized construction doesn't require a company to kind of gobble up everything in order to be successful. I say it to the design team all the time that I really am creating a whole bunch of product designers. Like, I'm not necessarily trying to create the best architect. I'm trying to create a thought process, really a way of approaching a problem in a way that is manufacturable and buildable. So how do we approach design? I think I did all of my schooling at Rice, and we had this constant question around form or function, right? Are we about how it looks, or are we about how it functions? And I never won that argument because I don't believe it's about form or function. And it's not something that is popular to say in certain environments. So I feel like I'm in a really great room to spout some design principles that may be popular or not popular. So I don't believe that design is about form or function, and I don't believe design is simple. It's actually to create something that is not only cost-effective, beautiful, and a customer and client want to live in. It's actually a really high bar. And it's also a very highly regulated profession. So it's about need and desire, ease of interaction, ease of manufacturing, but it's also about brand differentiation. And we can learn a lot from looking at other areas of expertise and not just focusing on design. So the first thing we did was look at assign and understand who casts the biggest shadow, right? Not because we're trying to give architects or designers big heads. We're just trying to look at the economics and understand where people spend their money. And typically, people don't spend their money on design, right? If you're talking about a product that's going through the market, at most, you're looking at spending 5% on the design of that product or project. That's not a huge amount in the whole value stream, right? So it can often get ignored, it can often get marginalized. It can also mean that the companies that are in that space in the AEC sector start becoming really combative and protecting themselves because there can be little margin there if you're not really really good at running your business. So this slide is really talking about what shadow does design or engineering or product development cast? What are the things that are coming out of the design process that affect the product that you're doing? And I didn't make this up, but it's about 70% of the items that are touched during that 5% of the fee are decided in that design process. And it doesn't really matter what you do in terms of material negotiation or supply chain management, although those are really important. If you can't get the design to where you want it to be, you can't really reduce the cost. And your labor, there's arbitrages you can do, put your factories in various locations, outsource labor. There's ways that you can do that there, but there's little cost savings that you can really gain. So what the thought process in developing this design team or this design ethos is really, you can affect not only project size, build less, build more efficiently, affect sustainable construction, you can affect building specifications, you can affect construction detailing, you can affect manufacturing throughput, you can affect all of the things that are maybe less so often aligned with the design process. And then you have to pick which lane you're gonna be in. Do you wanna standardize or do you wanna be flexible? And this is another age-old struggle. And I think that there's business models that work that land on one side or the other side or in the middle. And I think you just have to really understand what markets you're solving for and what your business model really is in order to understand what the solution is for you. For us, we didn't choose standardization or flexibility. What we did was understand what amount of variability we wanted to allocate for. And part of that reason is because we don't just operate in one region. A lot of the successful volumetric modular companies or panelized companies really do so by kind of owning one region, right? Like know the model that you're building, know where you're going, and optimize the heck out of it, right? I think that is a way to be successful. With the kind of natural growth that VBC has done and opportunistic growth that VBC has done, we have had to operate in a lot of different markets that don't necessarily have the same regulation. So we've had to find kind of threads through that in order to be successful. So for us, it was about understanding what the market wanted, specifically the US market, which has a lot of very specific desire to have things not look the same. And me as still practicing architect, I also have that desire. But I also know that for me, problem solving is the biggest thing for me. So how do we find things that maybe we think are different and find a platform approach to understanding how much of those items are similar so that we can use that to generate and replicate standardization and not necessarily be building the same thing. So what we have done is we've said that we provide standardization where it provides the highest value to the manufacturer. Parts, components, where we need to go through and regulate our supply chain and negotiate with our supply chain, we don't want to mess that up. So we provide standardization where it has the highest value for the manufacturer, but we don't alienate the customer, right? So we have to provide variation where it has the highest value to the customer. And often our customer is not necessarily a developer, our customer is the developer's agent. So architect, engineer, funder, whatever that is. And all of those groups and stakeholders have very different goals. So for me, I find myself appealing to architects more, understanding and talking to them about what levels of flexibility that they can use to ensure that they are not the ones responsible for breaking the budget. And so what we do at VBC is we're above the line. We want a product-based delivery stream. So anything that is kind of niche, low volume production, we will say no to. That was something I heard earlier that I kept nodding my head about. We have to be willing to say no a lot. And then where I think construction mostly is these days is below the line, right? Niche production or job shop, design and then build, or design and then build and then design more while you're building. We really try to stay away from that, and we're trying to attack everything that is kind of high volume or high adaptability for our strategy. And we've taken lessons from other industries, right? So this slide and the next slide speak to housing is not, right? Housing is not fashion, right? It's a completely different ecosystem, but what can we learn from the retail industry? I actually really like the idea and thought process of Gap and how it's evolved, Gap Inc. and how it's evolved. So they have a brand that a client can grow with, right? It's not only aspirational, but they cater to their audience where they're at in their life. And that's a really interesting thing to think about if you're talking about crafting housing that people want. And they have strong internal processes and things that can ties through Old Navy, Gap, Banana Republic, and Athleta, that they can aggregate certain things centrally to gain cost benefit for all brands. So, and then they also adapt or die, right? They've seen things change in the fashion industry and tastes change in the fashion industry, and they allow for change but still maintain brand recognition. So it's one of the things that we studied in development of the platform. And then housing is not. Housing is also not a car. I wish it was. I really wish it was, and in certain markets it is, but it isn't if you're trying to think about things at scale, at least in the US. But what can we learn? Standards are critical. You have to know what you're building with. And you have to have a voracious knowledge of what you're building with. You have to understand exactly how it works at every level. And you need to manage iteration. I was hearing earlier that, as you're walking up a mountain, you can't stop and say, I need to change now that I'm walking up the mountain. You have to get there and then do iterations. Iteration planning is so key, and strategy, and iteration planning for strategy is often a very strange thing, right? Strategy doesn't have to be all-encompassing and all-changing. It can be progressive, and that's one thing that we've really adopted at VBC. And we need to be flexible, and we need to have the ability to pivot if we see market changes happening. And I think what we looked at here was Volkswagen and Audi. I think they're a great Volkswagen Group. It's a great model for how we can think about things maybe slightly differently than everyone, and gain the not only brand awareness and brand allegiance, but also innovate. So how do we think about all of that, and how did we put that together in our platform? So I like to talk about it like a Russian nest, like a nesting doll, but you can talk about this in a lot of different ways, right? Components, base modularity, there's lots of different ways that you can speak to this. So graphically, what we do is we know the components that we make with, right? So whether that's a faucet or a stick of lumber, and knowing that, the structural capacity in one factory versus the other, and having parts and pieces that we understand every bit of, is our first step. We call it our base level 0. And those are the pieces that we build every project with. And those pieces can be nested into kits, that next level up, right? So there's cost savings, there's time savings, there's manufacturing savings, and speed by building with building with higher level products, right? So if I have a project that's all level 0, which we don't do, it would be faster than traditional design, and it would be better because those pieces are designed for manufacturing, but it wouldn't give us the full benefit. So by nesting that into kits, kitchen kits, bathroom kits, other things that are essentially assemblages of those components, we gain speed, efficiency. Then jump to the level 2 product. What does that mean? We call them CBUs. We also use 3-letter terms for everything. So you can talk to me later about what that means. But they're units and typologies that we know that group a whole bunch of different kits together, right? Mechanical kits, furniture kits, kitchen kits, bathroom kits, and they are designs that are pre-selected that we know work. And we have catalogs of where they have been used in various locations. That's level 2. Level 3 is something that we're really super stoked about, or I'm really stoked about, and it's really taking that nested philosophy to another level, and it's really saying, okay, well, what would we do if we essentially take the last 5 feet of a building or the last 5 feet of a modular, volumetric modular box and say that that's free to do whatever you want with, but everything on the inside, we prescribe. That allows us to then fully engineer everything in that module. And that's for us what level 3 is. So that's something that we're rolling out very soon, which we're really excited about. And that's, I think, where we see some real change and some massive benefits to throughput in the facility. So, and then this is just practical views of what those levels of product look like, right? So our base level product is standards. We need to know how we build for both our steel and wood systems. What are the typical connectors? The things that you need from an architect, typical details, right? But typical details that have work instructions that are associated to the factory, videos, things in Spanish and English that really are not just about design, but go all the way through manufacturing. We also have standard pieces and products and components that I mentioned, which you see on the screen. And then have a description of that blueprint so that other people understand what the design framework is for that system. And then what does level 2 look like? Level 2 are these kits that I was talking to you about. So pieces and components that can be toggled between and bill of materials that are very specific to those elements that speed manufacturing. Level 2, these CBUs that I was talking to you about. So fully designed, optioned, and rendered. Pieces that can be rapidly deployed in configurators for either us to use internally or external customers to use. We have not rolled out that external function yet. And then for me, level 3 is what I'm very excited about. It's really our concept that you can divorce the exterior of the building from the interior of the building, and by engineering that quickly, you can take something that is a configuration or a configurator and really turn that into a building configurator, manufacturing configurator, and know not just that you're producing all of the documentation, but that you're producing all of the BOMs that make it actionable for manufacturing. So that's what we're working on. And thank you for having us, and look forward to your questions.
Thank you so much, Sarah Ann, and it's really fantastic to see the developments in VBC. Our next speaker, who I'll invite up, is Oliver David Krieg, or he goes by OD. And I was going to introduce him as the CTO of Intelligent City, but I have just heard a little bit of breaking news. No, he just told me that it's now president of Intelligent City. So you heard it here first at the Industrialized Construction Forum. With that, OD, the floor is yours.
Thank you, Daniel. Stick to that one. Well, first of all, thank you so much for the invitation. And that was a fantastic presentation just now. So many lessons learned in there, and quite a lot of parallels. I also have a slide with the Volkswagen platform, although I think I deleted it from this one, so luckily there's no repetition here. I really want to comment on a lot of things that we heard this morning. I think there were so many interesting approaches, and I really like to look at these different companies as in where they are in their journey. Are they in building 1, building 5, building 50? How many factories do they have? How advanced and mature is their product platform? And we see ourselves somewhere in the beginning of that journey, although we started a long time ago, and I really see that as a common thread to innovate and integrate in our industry, it takes a lot of effort, a lot of time, a lot of commitment. The company was founded by Oliver Lang, who's in the audience, and Cindy Wilson, who are also architects and who saw that opportunity to combine design with manufacturing to develop a repeatable and adaptable product. I joined the company 7 years ago as CTO, and my background is in architecture too, so there's a lot of design intent, but also a lot of technology innovation that we are trying to merge together to basically get to a point where we have something like a product platform approach to housing where we can make buildings configurable. You're hearing the same keywords here, configurable products, right? Coming from a scalable and repeatable platform. We industrialize construction. We try to automate it. We are talking about adaptable automation or parametric manufacturing because we are using equipment and machines and robots that allow us to automatically transfer the data, even if the building components differ from one to the other. The sequence of workflows is the same. The code generated is automatic. And ultimately, we want to develop basically a building configurator that allows us to automate or at least augment a lot of the planning and delivery processes of these kinds of buildings. I think I'm the first one to talk about the problems that we have in the industry, but I think we all know about this. We all know about rising construction costs. We know about ESG requirements. We know about the problem with construction is that it's one-off in 3 dimensions, different teams, different time scales, different locations. There are so many challenges to really innovate in our industry consistently, and yet we do have everything that's needed. We have, especially when it comes to wood construction, we have the forests, both in Canada, where we are from, but also in the US, of course, to really get there. So for us, the solution was a product platform, and specifically with mass timber, to go into the urban housing market. So we are developing or have developed a product approach to what these buildings can look like, how we can use a kit of parts that is adaptable, configurable enough to design many different types of mid-rise to high-rise buildings. We're using offsite manufacturing innovation to automate the manufacturing of these components. And then, of course, we also really need to look at the on-site assembly processes and how these building components come together. Another diagram, maybe we can add that to the ones we saw just now. I think it's very complementary. When we go from project to product, a lot of things change. A lot of these typical methods that we as architects in particular, but also in the construction industry just in general, have been accustomed to change. I want to just highlight a few of those. I think the goal is an interesting one. When we talk about building buildings, we talk about the completion of that building, and then we drop everything and we are happy we made it through it. Whereas on a product mindset, we think about a continuous development process, iterative, and then about consumption of that product. So it's a continuous process. The team stays the same. It continues across the iterations, and we have a more permanent life cycle rather than sort of start to finish. That is one mindset that is very different and actually very difficult also to really introduce throughout the company and throughout the industry when we talk to builders and trades. Because there's no incentive to do otherwise, right? So ultimately, the product platform for us is not a volumetric. We are looking at flat-packed kit of parts, and we have a certain set of core components that we manufacture ourselves. This is the envelope of the building, the structure of the building, and some mechanical electrical integration. And then we have complementary components that we want to build an ecosystem. I want to talk to Rich about the bathroom parts. We want to integrate interior, partition walls, balconies, exterior accessories to build this sort of OEM ecosystem that we see in other product-based industries like car manufacturing, where the OEM ultimately sources from many different suppliers, but the interfaces that connect them are standardized, right? So we can have different bathroom suppliers, different kitchen suppliers. It interfaces with our buildings, and it works together, depending also on the location, of course. So when we look at product family and ultimately the individual projects, they can differ significantly, especially in the multifamily housing market, where the shape of the building is very dependent on the lot, the regulation, the city you are in, and sort of accommodating all of these variations is truly what is, we believe, the key to success. Can you accommodate setbacks, balconies, hangovers, or any other sort of type of building? When you go between low-rise and high-rise, things change, right? Building codes change in different jurisdictions. These are the situations we need to accommodate to be able to serve a large enough market segment that makes sense for us to invest into these technologies. But when we do talk about product, we talk about usually 3 different sections. We talk about low-rise, 3 to 6 stories, where we are competing against stick frame. We're talking about the mid-rise market, where mass timber construction is really very, very promising. It is cost competitive or even cheaper than concrete if you do it right. It is especially faster than as well. And then you can go up to 18 stories now in many states and provinces to go real high-rise and to build larger developments. So when we look at the technology that we developed, we kind of divided up into 3 segments. One is the physical aspect of it, the building systems, the kit of parts, if you will. So all the details, how do things come together, in which situations, right? What you're seeing here specifically are, again, the things that we make, the floor panels and the envelope panels. We develop our own manufacturing processes. We're talking about mass timber. It's a new building material. How do you prefab or manufacture with mass timber is different than with stick frame. So we took that opportunity to innovate a little bit ourselves in this regard. And then on the design side, now that we understand our systems, we understand what is possible, we can also develop software or tools and plugins that help us design buildings within that realm of what is possible, within that design space. And so ultimately, another thing that changes is you go from designing projects to configuring products, right? And I think this is a really important change, and it really touches on that sort of major challenge that we have in our industry, where you have the architect wanting to customize, and you have the developers who expect a certain customization for their own branding, whereas what we as manufacturers want to do is standardize, right? And so that sort of balance between how can I enable customization within my kit of parts to allow for that, while still keeping the manufacturing processes standardized or similar enough so that they don't upset my manufacturing process, right? So this can happen through software automation, through manufacturing automation. It can happen through a set of standards, right? Can your windows be all different sizes, or can they only be 6 different sizes? There are decisions we take every day when we develop our kit of parts that are really, really minuscule, but have really important consequences on design freedom. And I think that's really the key to making this industry successful, is to finding that balance. I think the VBC is doing a really good job at that, because this client-oriented, what do you need to feel comfortable with the design of building? What kind of variability do you want? And still having that as part of your components, where you can just still go manufacture every day without changing too much. So the last few years, we developed and tested and certified these building systems, again, for mass timber, geared towards high-rise urban housing. We like to say starting at 4 stories, and then mostly going into the high-rise segments. 10 to 12 stories is really where the performance of mass timber buildings shines. So to dive in there real quick, because it has an impact on design and variability, we make floor panels or floor cassettes. These are actually double-layered floor cassettes. They have a hollow core, and there are services inside. So we're trying to flat pack and still prefab as much as possible, electrical and mechanical systems. And these floor cassettes, because of the way they are made and put together, they can actually go wider than your usual piece of CLT, and they can have multiple spans to accommodate different structural grids and layouts. Again, this is one of the floor cassettes you can see here. You can see how it's double layered. It's actually glued together. And then we have our envelope system that is, again, high rise. So it's a curtain wall system. It hangs from the structure. And it accommodates essentially all kinds of geometric situations. You go on corners, interior corners, exterior corners, balconies, parapets, and so on. And the variability here is a geometric variability and a spec variability as well, right? You can have different types of windows, different types of claddings. This is really where we're pushing really hard right now to figure out what kind of variability is needed, what kind of energy performance is needed. What you're seeing here is 8 inches of insulation on top of 4 inches of, 4 inches of CLT. So this is a really thick Passive House certified panel. This is how we tested them. So they are Passive House certified or can be Passive House certified, high energy performance. And ultimately, this is what you get from us directly, is the core and the shell, the structure and the envelope. It has a clean ceiling. You can see that here. The way we designed our floor cassettes is that you have the fire stopping layer is the bottom layer. So you have a clean sheet of CLT basically on the bottom, and most of the services come up from the floor upwards so that we can keep that fire stopping layer relatively simple. And again, maybe a parallel to the previous presentation here, the key or the cornerstone to enabling this flexibility and to integrating design into manufacturing is really, I think the cornerstone here is the apartment layout, because that's where everything comes together. That's where your services get identified where they go. But it's also really in relation to the structure of the building. And because we make the floor cassettes, for us it's really important to tell the client and to work with the architects to say, look, this is the structural grid of your building. This is how the apartments need to fit in there for that to make sense. And this is sort of also maybe the point where you have the most conversations and you need the most collaboration, because here is where the ideas of the developer, the marketing department from the developer, they clash with what's possible, because oftentimes developers are used to basically infinite variability, right? And they look at square feet of apartments rather than overall efficiency. So you have sort of the local versus global optimization problem. You look at a single apartment layout, you want to make it 10 square feet bigger, but in return, overall the building gets more complicated and more costly, right? And I think one of the big success factors for us as an industry is to communicate that if you accept a certain level of standardization, you get a better building for less, ultimately. It's the whole approach, right? All of the financing. I think one of the presentations said that earlier today. It's not. I think it was 50 million, right? It's not just the construction cost. You look at the financing cost of money. Look at when you have a return on your capital. Look at change orders. These things affect ultimately what your finances look like, and so having some level of pre-engineered standardization, even if maybe some apartments are less efficient in that sort of perceived logic, the overall building is more efficient. So that's a big impact on sort of, I would say there's manufacturing-aware design, and there's also sort of product platform-aware design, right? And when it comes to manufacturing, we implemented a few sort of robot cells or automation centers where we think it adds a lot of value. It enables us to produce faster and more consistently. But what's also really important about DFMA is that if you employ automation, it affects your processes as well. The car industry is a great example. No one could assemble a car by hand anymore nowadays the way cars are made. The process, the parts, and the manufacturing equipment all develop together, right? And in construction, a lot of the processes and the materials are or have been developed to accommodate 2 hands or a tower crane. And that sort of in between, where some of the industrial equipment comes in, hasn't really been explored. So for us, a lot of impact that robots, for example, have on production is that they can lift larger pieces, but not super large pieces. And they don't have as much dexterity as human hands have. So screwing big wood screws is really challenging for robots, but it's very easy for humans. So there is a negotiation of what the process really looks like and how the process changes when we use automation. Ultimately, we have our own CNC processing. We have an assembly cell for envelope panels, even an assembly cell for our floor cassettes. The range of automation is anywhere between 20 and 80% for these different products, and there's still a lot that we want to improve in the future. This is our first facility, so where are we in the journey? We ramped up our facility just last year and produced our first project. And it's just a 15,000 square foot facility. It's actually really small. It can make up to 200, 250 homes a year, or at least the components for those homes. And we keep ramping up, and we're looking at expanding as well. So just another small comment about software. If we know how this all works, we can automate it. That's, for us, really important. Architecture is not scalable. The architectural planning process is not scalable. So we really want to find a common ground, a common data environment, and then slowly augment the design processes, automate how apartments get put into these buildings, how the structure gets automatically generated, and analyze the data as well. So that's it's become almost a side project at this point because we're really focused on manufacturing, but it's still something that we're working on in terms of the common data environment, so have a sort of a seamless flow from design to manufacturing. And one other point here, again, is sort of looking at what's the impact of that on design. Well, parametric design has oftentimes, well, for the last 20, 30 years, mostly been used to create really complex one-off projects. Some of these projects are only possible because of parametric design, because you could program the design process. And then you have, on the very other side, you have sort of a one-fits-all kit of parts repetition approach. And that's where parametrics can assist us in allowing enough flexibility, especially in housing and commercial buildings, to adjust the geometry on the fly, to adjust it gradually without having an impact on the manufacturing complexity. So as one example, going through the motions of automating how different components and different parts are generated, the drawings being generated, and ultimately the manufacturing data being generated. So that was for us, actually we started in the back end of that. For us, most important aspect of all of this was to allow our machines to function really quickly. So loading the geometry into a plugin that would generate the robot code to then assemble our building components or machine our building parts. That's where we really focused on in the last few years. And then we're going backwards towards automatically generating the parts and then ultimately automatically generating the whole design of the building. So maybe the most important slide, in my opinion, is having a data flow that allows you to design a building with some geometry. That geometry is being used to then generate the building parts, and that geometry is being used to generate the manufacturing information. So as I said, last year, we were lucky enough to start production on our first project. It's a 9-story, 50-unit affordable housing project in Vancouver, BC. And we went basically through the entire motion of ramping up production, hiring a whole team, going really slow and then faster every day, and then ultimately making it on site. 122 Passive House certified facade panels that were at the end, 6 of them assembled per day. At the end, we made 8 or 9 per week in our facility, ramped up actually beyond what we thought was possible. And that's also a really big lesson, I think. The first time you develop a system, you develop a component, is when it's going to be the most complex and the most expensive, right? Because only at that point, when you are here on site and everything has been installed and all the little problems that cropped up have been figured out. You actually understand how complex it all is, and now you can optimize, right? So our product will never be more complex, it will never be more expensive than it was at that point, and it's really exciting once you've climbed that hill to see where the next hill is, where you need to go from there. Reaching that point is extremely hard, and I think everyone who is here today went through a very difficult journey to get there, so I really respect that as well. We have a really great team that helped us accomplish this. The next project is just starting up production. It's going to be in Toronto, another 9-story building. We're doing both the structure and the envelope, so hopefully I'll have some more videos and pictures in the future. Thank you.
Thank you very much, OD. And finally, we move to our last set of speakers, because it's actually 3 speakers. We've seen 2 examples of vertically integrated companies with a strong focus on the connection with the DFMA. What I think is really interesting here is that we're going to hear from a collaboration called Folia, which is really about kind of creating a shared understanding and development, co-development from different companies working together in a collaboration. So with that, I will invite to the floor, and I think they're going to also use the handheld mics as well. We have Aaron Jobson, who's the president and CEO of QKA Architects. Josh Carney, who is the president of GPLA, and Gino Cecchetto, who is with Blach Construction. I hope I got it all right. Welcome to the floor. Yeah.
Thank you. So I'm Aaron Jobson with QKA. It's interesting hearing the previous 2 conversations and then thinking about what we've been working on for the last 10 plus years and talk to you about, because we're tackling a lot of the same issues, but I think in a different context and in a different way. I'm realizing the remote is over here. So as you said, we're 3 companies that have worked together on this effort. So I'm with QKA, I'm the architect, and our core business is designing public schools throughout the Bay Area.
I'm with Blach Construction Company, Director of Virtual Design and Construction. I'm a union carpenter, been in the trades for 40 years, been with Blach 38, with all but the last 15 of that in the field as a project superintendent.
And I'm Josh Carney with GPLA. Actually, some of you might know Greg Luth, who was our founder. I'm carrying on that legacy. We're structural engineers with full fabrication detailing in-house. I don't know where Sarah is, but shout out to Pennsylvania. That's where I call home. But, you know.
So this is very similar to a diagram that Sarah showed earlier, which is, I think, a good example of how we're trying to solve some of the same questions. Thank you. And that is, in our ecosystem of designing and building schools, there's kind of 2 ways that they get built: custom site built or very strict modular. Many of you, especially if you're from California, are familiar with a portable school classroom, which is probably the most ubiquitous modular construction there is, and maybe the lowest quality, hopefully. And so usually we're kind of existing in those 2 worlds, and as architects having frustration with those limited choices. All right, either we design custom and we understand the trade-offs that represents, or we can use a modular system, but if we don't fit exactly with how that system works, as soon as you try to nudge that in one direction or other, you erode most of the efficiency, and it doesn't really work. And so what we set out is kind of really Gino and I and our companies being frustrated with that limited choices, doing the same type of buildings over and over again as custom projects, and thinking there's got to be a better way to do this for us, for our teams, but most importantly for our clients and the communities that those schools serve. How can we get them a better quality buildings?
I think we ought to point out that one of the motivators for this was that school districts never have enough money for the program that they need. And when you go after a custom one-off project, it becomes very challenging for them to get the programming that they need. And so what ends up happening is they kind of get forced to go to modular construction because it's the only way to get the space that they need. And it's if you care about what goes on for our kids, it's not a great choice. Right? They're not very inspiring spaces to learn in. And so when Aaron and I first started talking about that, one of the things that we wanted to achieve here was, give them a building that is the quality of the custom building with no compromise relative to the environment the kids are learning in, right? Trying to put kids in a great space to learn, but enable districts to be able to afford more and have it faster, and hopefully then avoid getting pushed all the way over to the point where they have to go modular.
Yeah. And I think another kind of point on a different spectrum that we're trying to fit is every school is pretty unique. You might think that all the classrooms are the same, that every elementary school needs the same stuff, but that's not really true, especially when we're not really working with new schools in subdivisions and greenfield sites. We're working on existing school sites and improving existing campuses. And so we needed a level of customization, and we knew that we were going to need a level of customization to make that work, but finding that balance between kind of what, in a different context than the housing context, about what do we customize, what do we keep standard, how do we make that work for every project?
All right. This is very different than the two presentations you've just seen, right? I mean, the story that we're telling comes from, we're a general contractor. We're a self-performing general contractor. We do about $300 million a year. We were trying to solve a problem that we saw over and over again in an industry, in a segment that's part of our core business. And so we weren't out to, vertically integrate and create, a huge space full of robots. We were trying to figure out, how do we, as in the grand scheme of things, a relatively small contractor, move the needle, change things, try to do something better. And so Josh's predecessor, Greg Luth, which many of you know, is a brilliant engineer, and Greg and I had met through Tekla, and we started talking about how you go about doing these things. And I mean, this is about panelization and modular, but honestly, I would tell you, that's not the win here. I mean, that's part of it, and there's a lot of things you have to do that. You have to think about, how do things grow when you put them together, panels, right? You've got to allow for 1/8 of an inch or 1/4 of an inch in between every panel, all of that kind of stuff. But the real win here is thinking about the guy in the field that has to build this. Like, yes, in Folia, we prefabricate rebar cages, we prefabricate the structural steel system at a level not typically done, right? There's no field welding in the structural steel system other than the deck. And we do wall panels, we do roof panels. But honestly, what really makes it happen is that we've spent a lot of time thinking about every single thing the guy in the field has to do. If you look at our footing system, it's a basic ladder-style footing system. All the footings are the same width. They're all the same depth, right? The only thing that changes when you come to brace frames is that there's more rebar in there. Well, what does that mean? It means that the guy in the field that lays it out does nothing but corner points, and he stretches a string across there and he paints it. The guy that comes along in the tractor to dig it, he's got a bucket the same width as our footings, and he just goes in a straight line. It's not like digging great big spread footings underneath brace frames where the guy's got to turn around with the tractor every which way to dig corners. To me, that's the win in what we're doing differently with the team, right? Is thinking about the guy every step of the way, the guy in the field that has to build it.
And I think what the magic, and you're going to hear us say this, and you're going to hear us repeat it over and over, was a level of trust. That as structural engineers, we knew that what we brought to the table was the understanding of how to achieve what Gino's talking about. Respecting the guy in the field who's actually doing the work, who we're trying to optimize their labor, their workflow, their process, and being able to look at design through the lens of not just did we check the box of the code, and by the way, DSA, maybe the most restrictive, difficult review code agency that exists on the planet, it feels like. And so being able to do it in that environment and have it really be about what's the process and how does this, this applies to K-12 schools, but there's nothing that we're talking about today that doesn't apply to any other type of building. And, I think multifamily is a great test lab in the sense that it does tend to be a repeatable module, but the truth is a lot of buildings aren't. And so the concepts that were developed through the relationship and frankly the listening to each other and taking the concerns seriously and obsessing about details. What really is the ideal detail that checks the code box, performs well in the building, and allows the craftsmen in the field to do their job efficiently without having to waste a lot of extra time. And so again, that trust piece is core, and it's not a technology platform. It's not a robot. It is a very human thing. And I think until the human piece of this really gets factored into everything we do, it's impossible to achieve.
Yeah.
Yeah, so, you know, relative to what we're supposed to be talking about, prefabrication and panelization, the things that I would say are very important. As a design team, you need to take the design all the way to shop drawings. That doesn't happen at the contractor level. That has to be done in the design phase. We go to bid with shop drawings, and that's somewhat challenging because, again, there's an interface that has to happen with the contractors, but we've seen over time that, like, if you look at our structural steel system, we've done, what, 28 buildings now, right? And the same structural steel contractor has done all of them but one, and that's one he didn't want, right? They didn't want it because of the geographic location. And so that makes it pretty easy, but relative to some other things, glazing, we've had different contractors involved. And so relative to shop drawings and stuff, like each time you have to figure out how you're going about doing that. But you do need to go all the way to shop drawings, and you need to represent that level of detail in the plan set, right? Like, I work for the contractor that builds these, and yet I'm still constantly telling these guys, like, we need more detail. You can't trust our guys that have done 28 of these to know each time how to do it, right? Like, you get a new guy mixed in, like, it's got to all be there in the drawing. So if you look at our structural drawings, there are sheets that show all of the rebar cages for the footings. They are designed in the modules that they get built, and it shows everything down to the rebar laps. It shows you the bars that you need to be nested into those cages to lap the cages, so when they get dropped in, the bars are already inside, they untie them, and they just pull them through. Like, you got to go to that level of detail. It's literally every nut, bolt, and screw, or this stuff doesn't work.
And I think that was one of the unique opportunities for GPLA. You know, if you know Greg, was never shy about doing something different. And so we're a structural firm with, as of today, 35 full-time structural detailers. You know, and we'll do 80,000 tons of structural steel this year and 20,000 tons of rebar. And so to Gino's point, if you weren't going to go to that level of detail and that level of understanding and that level of data to the trades, you know, you're not allowing them to do things differently. And so, you know, I think the whole team was uniquely positioned. And that's one thing I've come around to, which is there had to be a shared vision or this never would have happened. There had to be an absolute shared vision, shared commitment for all the different players to say this is worth us investing time to get it to work. And 28 buildings later, it works pretty well. And not every one of those was perfect, and there were lessons learned along the way. And I think Intelligent City, yeah, you're adapting, you're learning as you build, and I would love to hear more about your journey as you guys progress through it. But 28 buildings later, we've learned, I think, knock on wood somewhere, most of those lessons.
Yeah. I would say if there's any one message you take away from us, it's that you don't have to be a huge vertically integrated company to do this. All you have to do is have the desire, put together a team of people that, right, you have to have trust, and you can apply all of this to any project and move the needle. And that was, I mean, that's where we had to be at the beginning, because we had no intent of being a huge vertically integrated company. And you've seen time and time again examples like Katera. Someone tries to do it and they don't get there. So we're not, like, if you can't ever get a product to market, what's the point, right? And so for us, we're three relatively small companies in the grand scheme of things that just decided we wanted to do something different. And so that would be my key message to everybody, like, just find a team you can work in and have a desire and you can move the needle.
We knew we wouldn't follow the slides on this at all, so excuse us. So what Folia actually is a two-story classroom building. It's an L shape like you see on the screen here. As we said, we built 28 of these. None of them have actually looked exactly like this. We have a pre-approval from DSA, which we were in the process of renewing for a third time, almost there. And that is a whole process in and of itself that we could tell you about some other time. But we knew we needed to kind of balance the prefabrication and pre-engineering and kind of figuring it all out and being able to customize it. So mostly we do that by doing most of the customization on the interior and keeping the structural frame and the exterior as similar as possible, although we've definitely customized that quite a few times too. And working through our clients with that to understand the pros and the cons of that and the benefits and the trade-offs to get the project that they want that delivers the best value for them. If I can remember how to use the remote, there we go. And really, I think one of the things that we've learned in this too is that most of the value that we're delivering comes from compressing the schedule. And so this just kind of shows that we're able to, squeeze almost a year out of a design and construction schedule through, having some of it pre-engineered and prefabricated, through overlapping construction phases, through shortening construction durations, through a lot of design, streamlining too, with the client with that process and using our pre-approval. But able to compress that time, and that in and of itself is valuable to many of our clients, but it also delivers a lot of the cost savings as well by accelerating that process.
So, we already said there's been 28 of them, as Aaron alluded to. None of them are the same. All but a few, like total customs, are the same footprint, though.
More or less.
So it's designed around a completely open floor plan. There's no load-bearing walls or anything in the structure. So from an interior standpoint, we can pretty much do whatever the client wants. So they're all the same footprint, but they've all been changed to some degree to fit the programming that the districts need. Of course, like the other two presenters have said, there's a constant cycle of feeding information back into it, right? Being out in the field, talking with the guys that are building it, and figuring out, where things aren't working and then bringing them back in. We're in the middle, like this update we're doing now is pretty significant, changing the roof profile. We've also got a single story on the way that we're applying this to, but also relative to this success, we do this stuff on other buildings all the time too, working together as a team. I mean, we've got a process and it works. And, once you get this figured out, you can quickly get a lot of benefit in one-off projects, right? And it's the bane of our existence, really, if you're talking about efficiency in construction, but the reality is most jobs are one-off projects. Mm-hmm. So I think that's been a huge amount of success for us too, is just having learned a new way to work together and being able to apply it to pretty much any project we work on.
Yeah, because remember, every project is a different site, a different owner, a different code reviewer, a different inspector, and that will never change. And every state you roll something out to is a different set of rules and a different set of expectations. And so I think when you really, to Gino's point, when you understand this as a process and as a relationship process and how you build that relationship, those are translatable. Some of the technical details are translatable. We routinely use a lot of those technical details in other projects that are absolutely one-off projects. And so are we going to capture 100% of what Folia can do on that job? No. But there's nothing wrong with capturing 20% of it. And so I think it's to that point of we don't have to solve everything today, but we have to solve something at some point, and we have to start making sure it's repeatable, and acknowledge that, I don't know how many architects are in the room, design is still going to be design, and owners are going to still want their building to be their building. And yes, we can drive them to a certain discipline about that, but not a lot. And so how do you make this able to be replicated, able to be done over? And
I think, I'm just a carpenter, but if I had to make a forecast, I would say the more our industry gets closer to manufacturing and you start having products that are these kits of parts, that are volumetric modular, that gets put together, right? To be effective doing that, there's X amount of standardization that has to happen. I would hazard a guess that the more of those that get built, the less people are going to want them, right? There's going to be a point at which people are going to be going, I really want something that looks different. I could be completely wrong, but it's a challenge we go through on every job. Like every district wants their one-off custom vision of a classroom building, right? And then where we become attractive to them is when they realize they don't have the money and they're going to go get, you know, some horrible modular building that's going to cost them $1 million a year to maintain. I mean, that's the reality. We've talked to districts that are like, yeah, we saved $4 million going to this modular building, but it costs us $1 million a year to maintain it because the quality is so poor. So I don't know. I mean, I think as an industry, we need to find a way to improve the process on the custom buildings too. We can't just keep doing what we're doing.
I think that's probably a little bit of what has been a little bit different about this approach is we're not necessarily trying to like reinvent the whole process. We're trying to give our teams better tools to solve those problems and be really collaborative about how we do that and trust each other and listen to each other and ask each other questions in a way that is not typical of a typical design and construction process in service of, you know, delivering more value to our clients and to their communities. But doing that by really, we always talk about what we've done here is taken what we would have done anyways, which is a 2-story steel frame classroom building, and really just optimize that and figure out how do we do that same thing and deliver that same level of quality, but quicker and with less cost and more efficiently, and giving our teams better tools to do that.
Yeah, we have 1 minute. I think everyone can read or take pictures, but I think everything that's in there has been said. And again, remembering it's about acknowledging the field. The field is part of this process, and they must be acknowledged and brought into it. It's a teamwork issue. It's a collaboration. It's trust. And again, with no disrespect to the software, people are always going to be involved in this. It's got to be about the people. Thank you.
Thank you very much. You guys can stay. Good, so I invite OD and Sarah Ann to also come up. We have additional chairs to add. I think we have only 3 mics though, so we'll have to make sure we share the microphones. Oh, no, we have 5 mics, all right. Just 4. We only have to make 1 pass. Excellent. Yeah, and I think it's really inspiring to hear. These are very different orientations of companies with very different approaches. But for me, it's really inspiring to hear a lot of commonalities, a lot about the respect for people and for workers, a lot about the need to create value, a lot about collaboration and understanding the needs of different stakeholders. And I really want to focus this here on design and thinking about design because that's one of our focuses here. And yeah, we're also in an educational setting, so there are many students in the audience. I think I saw several earlier. And I want to ask for those of you that consider yourself designers or had a design education, and I think also for Gino, for you as someone who's worked with designers, what are the things that you wished you learned in your design education that you don't typically get, but that would be necessary? Sarah Ann, you mentioned teaching your architecture team to be more like product designers. So what are the types of lessons or curriculum changes in an architecture or structural engineering education that you wish that you had all received?
The thing that I wanted to change was waste. And so I think in my architectural education, I thought it was awesome. It taught me to think the way that I do. But I didn't get the value for other people's opinions in the education, right? It was a lot about advocating for yourself and making sure that you're heard and, advocating for the design and the built environment, which absolutely you need to be taught. But I think that there's a collaborative design process that I wish architecture schools taught more. And I'm seeing that happen a lot more now. I went to school a lot longer ago than it seems. But back then, I've been out for now 23 years. It wasn't about that. It was really about high design and how do you make something that is different. So I guess if there was something that I would ask that faculties do is really think about innovating, maybe not in the same way that they think about innovation, right? So what's the next form of innovation, and how can we make it so that the people coming in the profession after us have a better experience than we did?
We're not stopping.
I never get claps.
Oh, yeah, wow. OD, do you want to add something there?
Yeah, I want to echo that, and I think if I may take a more extreme stance, I think architecture education is not prepared for manufacturing-oriented, product-oriented, a product-oriented future of our industry. I think at least what I have seen when I was in education, it is a lot about design excellence and sort of that role that the architect likes to have of being the mastermind of everything, but not really taking into account what can actually be made. And so the result is architects oftentimes either underestimate what can be made and they're very conservative, or they overestimate what can be made and they go against the engineers and the builders. And that level of collaboration and humility, honestly, that you as an architect can only do what others offer to make, you can only design with that, I think is really needed in education.
Yeah.
I mean, I definitely echo those things. I would say, like, designing and building buildings is an extremely collaborative process, and architecture school is not typically an extremely collaborative place. It's just, that's not set up that way. I think it maybe is changing a little bit, I would say that architectural education is a two-phase process of formal education and experience, and those provide different and complementary things. And I think the other thing I'd add is, one of the things that we continue to struggle with as a firm is how do we teach our young architects how things get built, and what that process looks like, and how to think about that when they're designing things. And that's hard because we don't build things, so it's hard to do that. And that's something that we had a strategic planning retreat on Friday, and we were talking about how do we change the way we do construction administration to provide more hands-on experience for people so they can learn that. So I think that's the other thing. I don't know if that's a role for architecture schools to play, frankly, but just being aware that that is an important thing to learn, and just listen to people. I think a huge part of the success of our process has been the trust and the relationships, but also the openness for Gino to tell me we need to do something differently because it has to be built this way. And then sometimes for me to say, yeah, but that's ugly. And have it back. And sometimes he tells me that's ugly, and that's okay too. We have that trust and relationship, but also just, it's really important to listen to our engineers, to listen to our clients, to listen to, a big part of what we do is listen to teachers and listen to students and understand what they need, even though we might not think of it that way or understand that way or value things in the same way that they do.
Yeah. And Josh, what do you think from structural engineering perspective? Is it the same? Is it different?
Yeah. I mean, from an engineer's perspective, my wish that I'm, by the way, never probably going to achieve is that every structural engineering student should spend a year or a summer out working construction. Until you've picked up a number 11 bar, you shouldn't be telling somebody else to pick up a number 11 bar. And I think until faculty can replicate the experience of a rod buster or iron worker telling you that you're a dumbass and you shouldn't have done it a certain way, you don't appreciate the difficulty of the field. And so my wish is that every engineering student doing structures spends a summer working construction in the trenches on the, up with the iron, and really understand, to your point, Aaron, there's no other way to duplicate it other than being out there and hearing it from these tradesmen that have been doing this for so many years. And many times in my early career, I had a detail and they said, that's a terrible detail. I said, well, okay, what would you do differently? And I'd do this. And I said, but that doesn't make the engineering work. And he said, well, what would? And we had this conversation standing in a trench of all places. And it led to better details, and it led to a better understanding and a more constructible product. And I think somehow we've got to figure out to build that into our education.
Yeah.
I don't know how that works at a level because it's hard to drive it.
Yeah,
It moves the needle.
I think there's the commonality I see with all of you is the idea of this feedback loop. Whatever whether it's the man in the field or the robot, there's this feedback loop about what works and how do you create that feedback loop in the design space. I have so many questions, but I want to get to all of your questions because we only have so much time. So I see a question here, Ray in the front, and they're coming around with a microphone. And if you have other questions, feel free to raise your hands.
Ray Levitt, previously Stanford University faculty, now with Blackhorn Ventures. And so for Gino, Josh, and Aaron, my dad was a structural engineer. I worked in construction. The incentives typically are established in part by the contracts. So I'm curious, you may have heard about IPD, which Martin and Dean and others, have promoted. What is the form of the contract between the three of you that shares the risks of the warranties that others have talked about, and that shares the costs and the benefits of the collaboration, the profits out of it? Because typically my experience was when it's design build, the contractor hires the structural engineer on a fixed price and the architect on a fixed price, or pretty close to it, some percentage of the building cost. And then the incentives are not aligned. So how do you guys work that out?
So I think the shortest way to answer that is we don't really have one. And we didn't start this with a contract. And at one point when we were going through this, I put something about contracts needing to line, and Gino's like, nah, it's not right. because eventually we have an MOU, and there are things that are standing, but that was probably 5 years into the process before we had that in place. So it started with just wanting to work together and figure this out and trusting that we'd make it make sense. Now on our actual individual projects, we have an MOU that kind of governs how we'll share risk and share responsibility for the product overall. And our individual projects, we can't use IPD with public K-12 schools. It's not allowed. We do some design to build projects. We do what are essentially negotiated bid contracts. They're called lease back because that's a legal loophole in the school world. So each of those projects we set up in a way that makes sense for all of us and makes sense for our clients too. We have to sell all this to our clients, and that it's a value. It can't cost them more, right? And so for the most part, they function as design build projects, but in a way that it rarely is a collaborative design build. It's not a builder hiring an architect to give them the cheapest design fee.
Right.
None of that matters though, right? I mean, we work together exactly the same way every time, like it's a collaborative design build process.
Yeah, and I'd say to go further, for example, we carry 2 contracts. We carry a contract with QKA in the design phase. We carry a detailing contract with Blach for all the fabrication modeling, and that helps sort out some of those liability flow-through concerns. But it does not change a single thing about how we actually do the work. So we're actively, all of that for us is a single workflow, but because there's contractual structures, you figure it out. But it started with a joint understanding. And I want to be really clear in all of this. We are not doing this because we are losing money doing it. and with respect to nonprofit organizations, none of us are a nonprofit. And so it is a fair deal, and it is a good deal for all of us, and it is one that incentivizes us to do more together. But it started out, like you said, it started out long before the agreement with a shared vision of it.
Yeah, I think that's a really important point about it's quite profitable and lucrative when you have these types of trust and builds on. Okay, we have many more questions, so I want to make sure we get to them. We have one over here. Yep.
Hey, my name is Ben Stockner. I'm with Southland Industries. We're an MEP design build group. Many of you guys have spoken to typical or standard details or layouts when it comes to kits or configurations, and some of that may be visual, some of that may be functional, but there's also a technical aspect to details, structural details, for example. How do you segment out your structural details and the technical requirements of those details to where you have enough to fit the scenarios that you have, but you're not, how I guess, non-granular enough to where you're overkilling most of the time, if that makes any sense. I can say it another way if I need to.
I think it definitely, yeah, about how do you manage the interfaces that you have a robust but not too specific yet repeatable. I don't know, Odie, do you want to take this one as, dealing with mass timber? It's a newer material, so you've probably had to think about this a lot.
Yeah, I think Sarah and I probably have the same answer to this, which is you have to navigate between, again, it's a local optimization and a global optimization, right? You take, for example, we have steel column connectors between the floors. We have glulam columns. They go into a steel connection detail that goes to the next level. Depending on the building height, you have higher loads, you need more steel, bigger columns. So now you can optimize that to save material, quote unquote, but in return, you have 12 or 24 different steel connectors, and now you can't source them efficiently. Instead, if you simplify it to 1 or 2, you can get 1,000, and you get really good throughput. The supplier is happy, we are happy, we get a lower price, and ultimately the building is actually cheaper. So there is a balance between material usage and standardization and sort of the perceived efficiency in these single details. And that goes through many decision processes and material thicknesses and all of these aspects that touch structure, code, design, fire safety, especially in timber construction.
I think there's probably more that can say. Oh, Sarah, you want to go ahead real quick? Okay, I want to get to a few additional questions. Yeah, anyone? Yeah, Renata, yeah.
If there are students, please, you have the front row. Thank you.
Introduce yourself.
Renate Fruchter, CIFE, Stanford, founding director of Project-Based Learning Lab, and I wish you should have signed up for the AEC Global Teamwork class. Your dream would have come true. We do that for 32 years now and counting. Question for you. Thanks for inspirational talks and partnerships. Fantastic. And you have given us great gold standards for DFMA, Design for Manufacturability and Assembly. Last year, together with DPR, we challenged our students to actually address what we call DF Madre, Design for Manufacturability, Assembly, Disassembly, and Reassembly, as we think about, how do we design for the future generations and, sustainable design and construction. Any thoughts on your horizons towards a platinum standard?
Ooh, that's rough. For me, I think there are international companies that are really, there are Japanese international companies that are actually really doing this well. I think for us, it's really about how do we create flexible space that could be renovated later. I think the wood product for us, it's on the roadmap that we create kind of demountable connectors for wood. Definitely what we have currently in the steel system is the connector is designed to be demountable. So I think that is, for steel, I think it's a little bit easier to do than it is for wood. So I think I see the market going really heavily in that location or in that way. I think you probably have a really, and maybe Lindbach's too, because of kind of mass timber or glulam elements maybe get destroyed a little bit less than the light frame that we're working on. But having those connection details that are easily demountable are the key for utilization later.
Good.
The connections we have are demountable, and in fact, that has come up in discussions. Of course, it is, I have to say in truthfulness, it is not an important aspect when the rubber hits the road and it's all about cost. Everyone is super focused on just even making it work once is a really big achievement. But when I look at all our connections, the envelope, the columns, the floors, they could all be taken apart again. Nailed connections are more difficult to recycle than screwed connections. So there are certain aspects in that where I think it is certainly possible. And when we look at the GHG emissions, we should consider a balanced end-of-life scenario, right? We should not consider it all being burnt or going all to waste, but having the goal should be, 1/3 waste, 1/3 energy, 1/3 reused. And I hope that can actually be proven in the future. I don't know. We haven't had many mass timber buildings that are being recycled at this point, but maybe we'll see that.
Yeah, I think, unless there's a really quick thing to add, we have just time for 2 more questions. Alyssa, did we have any online? Yeah, why don't we go to the online? Yeah.
Okay. From Julian Feline from Nordic Structures. This is for Sarah Ann. You mentioned that, at least for now, you only manufacture modules using light frame timber in your Tracy facility. Have you given a thought to manufacture models using mass timber like CLT?
Oh, you guys are putting me on the spot. So I think, in 2020, we looked at a lot of things. We did some collaborations with the Tallwood Institute to think about defunct factories and utilization and designing CLT, those factories that used to produce light frame and transforming them into CLT volumetric modular plants. I think that there are legs there. I think it's really, for me, it's about access and dedication of resources towards that product design that we haven't been willing to spend yet, just because we're in so many different markets and so many different materials. I think the way we're looking to use mass timber is really to substitute out maybe concrete and steel at our podium levels for mass timber. We think that's a very, very, that really has legs, and I think it's something that can be incorporated rather easily into what we do now. So that's what we've been looking at in terms of foundational and podium building design.
Thank you, Sarah. And we have one last question. I see a hand here. Please introduce yourself.
Hey, RJ Mahadev, RAP, Rooms as a Product. It's an IC platform for hotels and multifamily housing. I think my question to really all the panelists is, how do you think of product revenues versus project revenues and intellectual property ownership?
And sorry, the last part was intellectual property? Okay. Yeah, open to anyone?
That is not a softball, RJ. I think, for me, this is what is exciting, right? I think if you can have an architect speaking on IP and technology potential ownership, I think that is not something I ever thought I would be doing when I went to architecture school. So I think that, in terms of, there are ways that products make money and there are ways that projects make money. And I think by blending some of those, I think it would be a really interesting way to develop idea sharing that maybe that's a little bit more open source. I think what I'm loving about the Folia group is that there is an understanding that you bring different things to the table and working with people who are specialists in something else, right? And I think that if you think about, rooms as a product or licensing technology, I think that having people in the room who are willing to benefit maybe in income streams that are not typical for them, I think the more innovative you are as a company, the more you're going to be comfortable doing that. And I think if you can get in those rooms and feel that trust within that group of people, I think you can go a long way. And I don't know that I answered your question exactly, RJ, but that's where I'm going to leave it.
And maybe if I rephrase it a little bit into Gino and Josh and Aaron, how do you think about your building system and I don't want to get too much into like IP sharing and things like that, but you've co-developed something together over many years with a lot of trust, a lot of knowledge shared. How do you think about whatever it is that you've created? Is it still just exist on a project by project basis, or does it have a kind of lifespan that's outside of your projects as well?
it's sort of both, I guess. It definitely has a product and a team that lives outside of individual projects. I hate to even call it a product because I think it's not really what it is. It's really like an approach that we developed, and we developed that together as a company. There's some intellectual property and contractual things that we hold together around that, and but it really is that idea, and then really that idea is in service of the projects. And one of the advantages we all have about being, small private companies is I don't even really understand the question between a product and a project revenue difference. Like that doesn't. For us, it's all from projects. The other is just expense that we put into developing it to get to this far. But I think that's really all shared and went into it pretty open about what those costs would be and what that return would be.
And I think it's a good point, because obviously we can have the greatest ideas on the planet. If nobody builds these, we've spent money that we're not recovering. So there's a faith aspect to it, and there's an understanding of the market and the market demands and the customer demand aspect to it. But I agree with Aaron. I mean, one of the upsides we had is collectively between the three of us, we can decide if we're going to do it or not. And we're going to decide if we're going to invest money for the next iteration or the next version or whatever. And we can always say no. But it's been successful in the past. Obviously, you have a shared belief that it will be successful in the future.
Yeah, fantastic. So, I think we have to. Oh no, go ahead, Sarah.
And I'm going to say something that's not popular too. Like, I believe that you should protect as little as possible. I think that you should be able to seed the next thought, because just because you're in a room doesn't mean that you're going to solve all the problems in that room. So I do understand that we need to all make money, and that's the way to change things at scale. So really figure out what you want to protect and what you're okay giving away for free. And for me, that's what it is. Like, I want to make things easier for everyone, and then specifically the secret sauce about how we put it together, maybe we protect that, but protect as little as possible.
I think we can keep this conversation going forever, but we do have to eat lunch, so I really want to thank this expert panel. Thank you so much for your participation.